Hello everyone, so today we'll be learning on the experiment for the factors affecting the rate of reactions. But before that, I would like to add something which I have missed out in my previous video. So we have learned collision theory in the part 2, but I have missed out one very important keyword, which is for the activation energy, it is actually the minimum initial energy in order to start a reaction. So please do not leave out the word minimum like I did, okay, because it is a very important keyword. So now moving on to what we are supposed to be learning today. So before I proceed with the experiment, I would like to recap on what we have learned in the previous video. So if you guys do remember, you have to remember, we have 5 factors that affect the rate of reaction. And the first one is what is the size of reactants. We all know that when the size of reactants becomes smaller, the rate of reaction becomes faster. And we have all the detailed bullet point which I have mentioned and listed out in the previous video. So if you guys have forgotten about it, so please do a recap. But to summarize, when the size of reactants decrease, the rate of reaction actually increase. And the second factor is the concentration of reactants. So when the concentration of reactants increase, the rate of reaction increase. And the third one is the temperature. We have temperature. We all know that when the temperature increase, the rate of reaction also increase. And next we have the catalyst. When the catalyst is present, the rate of reaction becomes faster, which means that the rate of reaction increase. And the last but not least we have is the pressure. When the pressure increase, the rate of reaction increase. So these are the 5 factors that we have learned that can affect the rate of reactions. So now we are going to learn on for the experiments. But for your information, the experiments we only have for the size of reactants, concentration, temperature, and the presence of catalyst. For pressure, the experiment is not in the syllabus, so we are not going to explain further on the experiment. So the first experiment that we are going to look at is the effect of size of reactants on the rate of reaction. So as we know that when the size decreases, the rate of reaction increases, and this is our hypothesis. This is our smart guess. We already know this. So now we are going to see how we can actually conduct the experiment. So the variables we have manipulated, which is the factor, the variable that we change, we have the size of marble chip, and the responding, like what we observe, we want, like for what we want to get, or the result that we are going to look for is the rate of reaction. And the fixed variable, or also known as a constant variable, is the mass of marble chips. We have temperature, volume of, and concentration of HCl. So what do we need? We need 0.1 molar of hydrochloric acid, large pieces of marble chips, and small pieces of marble chips, because we want to change. Remember, our MV is the size of marble chips. Yeah. And the apparatus, we need all these, conical flask, retort stand with clamp, burette, basin, measuring cylinder, rubber stopper, delivery tube, electronic balance, and stopwatch. Okay, so we know what we need and we know all of our variables, but how are we going to conduct this experiment? And here I've drawn out like the complete diagram of the experiment, and I'm going to break it down to you step by step on how you can do this. Bear in mind, I'm going to write it in as short as I can, but if it's in exam, please write the full sentence or the entire sentence, okay? So first what you're going to do is you're going to add in the HCl, okay? And we are going to choose the 50 cm cube of 0.1 mole dm cube concentration for the HCl. So we have one, what is this? This is a conical flask. Okay, this is one conical flask, and we are going to add the acid here, somewhere around here. Okay, and after we have added the acid into the conical flask, the next step that we're going to do is to set up the apparatus. Set up the apparatus as shown in the diagram above, which is this huge diagram right here. So it might look kind of complicated, but it is actually not, and we are going to focus on this part right here, like how are we going to set up this part, okay? So for the basin part, we see, okay, you can see that we have one basin, we have water, we have burette, we have retort stand with clamp. So what we are going to do is the first step on how you want to set up the apparatus as shown as in the diagram above is that you add in water into the basin. Okay, this is my explanation. You don't have to write this in your exam. This is for the practical purpose, which means you take the basin and then you fill up the water first. You have to fill up the water first, and next you fill up the burette. Fill up the burette with what? Obviously with water until the water level reaches about 50 cm cube. Okay, once you fill out the burette, what you need to do is you need to invert the burette. What does it mean by inverting the burette? It means terbalikkan the burette. You put the burette upside down, but you have to cover the tip of the burette with your thumb. Okay, if you want to turn this thing upside down, you have to cover it with your thumb here, and you invert it upside down. Okay, and once you have inverted it upside down, you immediately put it inside this basin with water. And after that, what you need to do is you just need to fix the delivery tube. What is a delivery tube? This is a delivery tube. Okay, you fill up the basin with water, and then you fill up the burette. Fill up the burette about 50 cm cube, and then you invert the whole thing, invert the burette, okay, using your thumb to close the opening of the burette, and then you immerse it in the basin, fill with water, and last but not least, you fix the delivery tube, okay, which connects the basin, the burette into the conical flask. And this is how you want to set up the apparatus. Is pretty simple if you understand that. And the next step is you need to weight large marble chips, okay, about 5 gram, and put into the conical flask. You put the large marble chips here into the conical flask. Okay, bear in mind, once you put the large marble chips into the conical flask in the acid, immediately close. You need to close it immediately because the reaction will start immediately, so you need to close it so that you can get a higher accuracy for your result. So you immediately close the conical flask, and after you close it, you start your stopwatch and swirl the thing. Okay, you close it, okay, with the delivery tube, okay, and then you swirl it, okay, you swirl it gently. So what you're going to do now is you're going to take reading. From where or at where? At the burette. Of course, at the burette every 30 seconds interval until whole burette filled with gas. And we are going to repeat all these steps. Okay, you are going to repeat all these steps using exactly 5 grams of CaCO3, the calcium carbonate, the the marble chips, except now you are going to use the small CaCO3. And after you have finished and complete the experiment, you will find that the time taken to complete the reaction for the small calcium carbonate is faster than the large calcium carbonate. Okay, so the first experiment that we have learned just now is about the size of reactants. So now we are going to look at the experiment for the effect on concentration of reactants on the rate of reaction. Now we are looking and we are focusing on the concentration. So we know that when or if the concentration increases, which means the solution becomes more concentrated, the rate of reaction increases. And yes, this is our hypothesis. So the manipulated variable, which the factor that we change is the concentration of sodium thiosulfate solution, and the responding variable is the time taken for the X mark to disappear from view. So how would X mark suddenly disappear from view? Like how? Why or how? Because sulfur will form. Okay, because sulfur will form formation of sulfur. If you know this experiment beyond, you know that okay, at the end something yellow color solid will form, and that is the sulfur. But if you don't know, it's okay because we'll get into that later. And the fixed variable that we have is the temperature, total volume of mixture, concentration, size of the conical flask. So what do we need? We need sulfuric acid, we need sodium thiosulfate solution, we need distilled water, white piece of paper, and you need to cross with an X mark at the center, which means that if this is an A4 paper, it is one white A4 paper, you need to take one marker and cross it. You put a cross at the center. So the apparatus is 150 cm3 of conic flask, stopwatch, and measuring cylinder. But before we get into any experiment, we have to understand what we are doing. We have to understand the materials, we have to understand how is it happening so that we can do our hypothesis, we can come up with a conclusion, and our experiment can run pretty smoothly if we know all of this. So first of all, we have to get to know the chemicals first. So the first one I write here is the sodium thiosulfate solution, is our ND. Sodium thiosulfate solution, you have to know this solution is colorless in color. It doesn't has any color. It's like, colorless solution, like a water. And then sulfuric acid, of course, is an acid, and we know that sulfuric acid is also one colorless solution. So basically these two are colorless. And in this experiment, we will mix this sodium thiosulfate solution with sulfuric acid, and then sulfur will form. So we have to know the reaction first. The reaction is this Na2S2O3 in the aqueous form. Okay, you react with sulfuric acid in the aqueous form, and then you will get Na2SO4 plus S plus SO2 plus H2O. Oh, sorry, I left out the aqueous. This is the solid form, this is the gas form, and this is the liquid form. Okay, so this is pretty much the chemical reaction. And this one, we know that this is the sodium thiosulfate solution. And this is our sulfuric acid. Both of these are colorless, okay? Bear in mind that both of these are colorless. They don't have any color. And then they will produce sodium thiosulfate. Sorry, this is not sodium thiosulfate. This is sodium sulfate. Okay, sodium thiosulfate is this. This is the thiosulfate and you produce sodium sulfate. And this is the sulfur. Okay, this is sulfur dioxide. This is water. And so because sulfur will form, so the X cross, because we are basically putting one conical flask on top. So when sulfur forms, okay, imagine sulfur, let me choose yellow color. Okay, when sulfur form on top, or sulfur form in the conical flask, at the end you will not be able to see the X cross anymore. So that is how we know the reaction has happened. Okay, as we know from the experiment from the previous page, the changing or the manipulated variable is the concentration of this sodium thiosulfate solution. But it makes, which means that you need to have a lot of concentration for this sodium thiosulfate solution, and it doesn't make sense, right? You need to have like 10 different concentration. So what we are going to how are we going to conduct this experiment is that we are going to be using only one concentration only. Sorry, we are going to be using only one concentration. But how are we going to, change from one concentration to we are going to make into 10 different one? We are going to dilute the concentrated one with water to make different concentrations. This is more like practical, isn't it? Okay, I've noted here, okay, the volume of sodium thiosulfate solution is how you make this solution. Okay, volume of sodium thiosulfate solution and volume of distilled water. I copy this table from your textbook. So if you want to refer, you can refer back to it. Like the first time the experiment, I'm going to explain how we are going to conduct this experiment first before I get into the actual steps. So the first time when you're doing this experiment, you are going to be needing 45 cm cube of this solution, and you don't add any water to it. So this is a quite, we can say, a concentrated solution. And the next time when you want to do this experiment, which is the second time, you are going to be using only 40 cm cube of this sodium thiosulfate solution, and then you add it with 5 cm cube of water. And the third time you use 30 cm cube of sodium thiosulfate solution with 15 cm cube of water. As you can see, the total we have is 45. Oh, I cannot write there. The total everything, when we total this both everything, we can get 45, right? But then the concentration is becoming, the volume is constant, the volume is the same, but then the concentration decreases over time because we are using lesser amount of sodium thiosulfate solution and of course larger amount of distilled water. So this is how you make one concentration into many different concentrations, because we want to do experiments for that. Okay, so now let's get into the steps. So the first step is that you need to use 45 cm cube of 0.2 molar of this sodium thiosulfate solution, which means you add the solutions inside. And then okay, you put this the conical flask with this solution, you put it in the middle on top of this A4 white paper or any kind of white paper with one X cross in the middle. You put it on top, and that time you still can see the X cross because nothing has formed yet. It's just one solution. So what we are going to do, the third step, is that we are going to pour 5 cm cube of 1 molar sulfuric acid into this conical flask. We are going to pour the sulfuric acid lah. You're going to pour the sulfuric acid. At first you have the sodium thiosulfate solution, and then you add with the sulfuric acid. But once you add the sulfuric acid into the conical flask filled with the sodium thiosulfate solution, you have to start the stopwatch, because the reaction starts as soon as you added the acid. You have to start the stopwatch, and you swirl and you put the conical flask back on the X mark lah, on the paper. You put it on an X mark. And when do you stop the stopwatch? You stop the stopwatch when the X mark disappear from view. Okay, when the X mark disappear from view, you have to stop the stopwatch. And of course, you have to record the time, because you're using a stopwatch. Obviously, you have to record the time. And then we are going to repeat. We are going to repeat all the steps, okay, using different concentrations of sodium thiosulfate solutions by diluting. How do you want to have different concentration? You need to dilute the sodium thiosulfate solution with water, okay, by diluting with water. Okay, you follow back this table lah. You dilute, the second time you dilute with 5 cm cube of water, the third time you dilute with 15 cm cube of water, and so on. So from this experiment, we can conclude, or we can get information that the higher the concentration, the faster or the higher the rate of reactions, which means the lesser the time taken for the X mark to disappear from the view. Okay, because, okay, recap back the previous chapters, we all know that the rate of reaction is 1 per time taken lah, 1 per unit time. So when the time becomes lesser, which means that the X marks disappear very fast, very fast from the view, and because it is inversely proportional, we all know that the rate of reaction is going to be higher. So this experiment is, okay, the MV, the manipulated variable, is about the concentration. But what if we want to change it to temperature? Because we know that, okay, the next factor, and one of the factors that we have is temperature. So for information, the setup of the apparatus for the concentration and temperature is exactly the same. The chemicals that we will be using are also okay. Oh, I forgot. Okay, I can't string my words together. The chemicals that we're using will be the same also. We are going to be using sulfuric acid. We are going to be using the sodium thiosulfate solution. Now we are going to change. We're going to look at what happened if we want to change if our NV, we change it to temperature. Okay, so now the third experiment, we are going to see the effect of temperature on the rate of reaction. So we all know that when the temperature increases, or when the temperature becomes higher, the rate of reaction increases. And this is our hypothesis. This is our smart guess. So instead of changing the concentration, now we are changing the temperature of sodium thiosulfate solution, and everything is the same. Okay, so this is what I've copy paste from my previous page. So note here, everything or all is the same except a few steps. So now obviously, because we are playing with temperature, you have to, in your first step, okay, when you use 45 cm cube of 0.2 molar of the sodium thiosulfate solution, you poured it into this conical flask right here. Yes, correct. But at the same time, you have to record the temperature, because since you're playing with temperature right now, you record the temperature. And as usual, you put it, okay, on top of the X mark, and then you pour 5 cm cube of 1 molar of sulfuric acid, you start the stopwatch and you swirl and put it on the X mark, and then you stop the stopwatch when the X mark disappeared from the view, which means when enough sulfur is formed, you can no longer see the X mark. And everything, okay, so far from step 1, step 2, step 3 to step 4, everything is the same. And what's different is for the step 5, because we are changing the temperature, we don't repeat using different concentration, we use back the same concentration, but we repeat step 1 to 4 with different temperature. Different temperature of what? Different temperature of this sodium thiosulfate solution. Maybe the first one is 37 degrees Celsius. Now we are using 50 degrees Celsius, 55 degrees Celsius, 60 degrees Celsius, and 65 degrees Celsius. Bear in mind, you need to have a minimum of 5 readings. So in here, conclusion that what we can conclude is that the higher the temperature, the higher the rate of reaction. Okay, so this is how you can see the experiment setup. The steps are almost exactly the same for the MV of concentration and the temperature. It's just that you need to change some things, okay, according to the common sense. So for example, I repeat, for temperature, you record the temperature and then you repeat with different temperature. If it's for concentration, you use the first, okay, one concentration first, and then you repeat with different concentration. By how you want to have different concentration, you need to dilute them with water. So that's it. Okay, so the last experiment is the effect of catalyst on rate of reaction. We know that when the catalyst, let me use blue pen, okay, when the catalyst is present, okay, when the catalyst is present, the rate of reaction increases, becomes faster. So in this experiment, we have to know that the catalyst is what? The catalyst is the manganese 4 oxide powder, okay, MnO2. This is our catalyst. So what do we need? I mean, look at the variables first. The manipulated variable is the presence of catalyst, which is the MnO2, manganese 4 oxide powder, also known as manganese dioxide. This is the other name. Okay, this is the IUPAC name, this is the other name. And the responding variable is the rate of reaction, because you want to see the rate of reaction if there is or there is no presence of catalyst. And the fixed, okay, is the mass of the catalyst, okay, temperature, volume, everything. And the material we need is this hydrogen peroxide solution, H2O2, okay, and we need the catalyst, which is the manganese 4 oxide powder and distilled water. So apparatus is the measuring cylinder, test tube rack, glowing wooden splinter. Why do we need glowing wooden splinter? Why? Okay, I'll explain it later. Okay, filter funnel, filter paper, okay, beaker, spatula, electronic balance. So as I've said before we want to know, or we want to conduct the experiment, it's very important that we know all the chemicals first. We know the reactions, we know the chemicals, so that we don't have to memorize the procedure blindly, and we can understand the experiment better and get a more accurate result. So first and foremost, we do this experiment, okay, it's by how we want to conduct this experiment is by we look at the decomposition of what? Decomposition of this hydrogen peroxide solution. Hydrogen peroxide solution is H2O2. When it decomposes, it will it will form H2O and O2. Okay, it's a very how can I say, the products, everyone know the product is water and oxygen gas. So like what I said in just now, why do we need a glowing wooden splinter? Because it will form oxygen gas, and we know oxygen gas ignites a glowing wooden splinter. So now we have know all the reactions, we have know the catalyst, we know what is the catalyst, we know what do we need. So now let's dive into the actual procedures. Okay, as you can see, I've drawn two test tubes with me. So the first step that we are going to do is we need to label. We need to label two test tubes lah, obviously, because test tube, they look exactly the same. We need to label. So I'll be using A and B. Okay, this is our test tube A. This is our test tube B. And the second step, okay, what do we need? We need to add 5 cm cube of this hydrogen peroxide solution into both of these test tubes. Into both of the test tubes. Okay, so this test tube gets 5 cm cube of H2O2, and this one also get 5 cm cube of H2O2. Okay, so far so good. So the third step is we need to add in 0.5 gram of, what is this? This is manganese oxide or manganese dioxide into test tube B. This is, bear in mind, this is our catalyst. Okay, we are adding catalyst only in this test tube. Okay, let's say we add, okay, because it is in a powder form, I'll use different color. Okay, I add in, okay, the catalyst, I add in here. This is the manganese M2. This is the manganese dioxide, MnO2. This is the catalyst. So, okay, so what is the function of catalyst again? Catalyst, for this reaction, it will speeds up the reaction. So actually, with or without catalyst, this reaction will still take place. The H2O2 will still decompose into water and oxygen gas. But with the presence of catalyst, this reaction becomes faster, which means that, okay, this B, they will produce oxygen gas first. Okay, they will produce oxygen gas first. This one, yes, it will also decomposes into water and oxygen gas, but maybe it takes longer. It takes way longer. And so the fourth step that we are going to test the effect of catalyst on rate of reaction is that we need to put a glowing wooden splinter into the mouth, not your mouth, okay, into the mouth of test tubes A and B separately. Okay, so now I will be putting the glowing wooden splinter. I put it at the mouth of the test tube only. Please don't insert the whole thing inside. Okay, so this is, according to the procedure, is like that. Okay, so what does oxygen plays a role? Oxygen, okay, it will ignite the glowing wooden splinter. So what will happen is that for this test tube B, the wooden splinter will be ignited. Okay, so you can see lah, a small spark of fire here, and this one, nothing happened. Okay, nothing happened. This one you see like small fire like that. So we know that the reaction takes place. Actually, both of the reaction takes place, but the rate of reaction for B is faster or higher than A because B contains catalyst. So now we can come to a conclusion that the B, which is with the presence of catalyst, okay, with the catalyst, the rate of reaction becomes higher because the MnO2 speeds up the decomposition of hydrogen peroxide solution into oxygen gas and water. That's it for all the experiments for this chapter. Okay, so before we proceed with the summary, I will discuss one structure question first. Okay, bear in mind that this structure question, the format might not be exactly the same because you guys are in Kssm, this is KBSM format, but it's okay because the content, everything is inside is still the same. Maybe just the marks distribution, but that's not important. So let's take a dive and look at this question. So Diagram 5 shows two sets of experiments that are carried out to study the effect of catalysts on the rate of reaction. Okay, they are using what? This time? They're using zinc and sulfuric acid. So let's look at set 1 and set 2. These two set, okay, it's the same. They have everything the same. But what's different is for set 2, they have catalysts because I've mentioned that they want to study the effect of catalysts on the rate of reaction between zinc and sulfuric acid. So for set 1, no catalyst. Set 2 with catalyst. So table 5 shows the result obtained from the experiment. So obviously for set 1, the total volume of gas collected in 3 minutes is going to be lesser than set 2 because set 2 is with catalyst, and we know that the catalyst in this experiment speeds up the rate of reaction. Therefore, we were able to collect more higher volume of gas in just 3 minutes time, and they keep the temperature constant. Okay, we can ignore this one because it's not important in this question. So the first question, what is the meaning of catalyst? Catalyst, the definition, catalyst is a substance that speeds up the rate of reaction. In exam, you guys write it full, okay? While itself remains chemically unchanged even at the end of reaction. Okay, that is your 1 mark. That is the definition of catalyst. So B, sketch a graph of volume of gas collected against time for both sets on the same axis, which means on the same graph you have to sketch for set A and set B. Okay, let's take a look again at the table for set the first set. Sorry, not set A and B, the first and the second set. Okay, the first set, okay, we have 40 cm cube in 3 minutes, while the second set we have 50 cm cube in 3 minutes. So okay, we see, okay, the y-axis we have cm cube, the x-axis we have minutes. So the rate of reaction, the graph because this one is the product graph, so product is going to increase over time. So this is your first graph. Okay, this is your graph, and we all know one is higher, one rate of reaction is higher than the other one. So we are going to sketch these two like this. Okay, because both of them, the reading is taken at the third minute. So obviously here we are going to draw these dotted lines down and label it 3. Yes, it's 3 minutes. And the first one, the set 1, we have 40 cm cube, or the second set we have 50 cm cube. So I'm going to my line. Okay, I'm going to draw this. Okay, this is 50 and this is 40. 40 is set, the first set, well, this is the second set. So here you get your 2 marks. So the first mark is, let me change it into the red pen. So first mark is when, okay, the shape of the graph is correct with the label of the graph. This is your first mark, and the another mark is your 50, 40, and 3, which means you label. This is your other mark. So you get 2 marks here. For just now the definition, you get 1 mark. Okay, so now we want to calculate the average rate of reaction for the first 3 minutes for both sides. This is very easy. We all know that the rate of reaction, the formula is change in the quantity of products or reactant. Okay, but for this is quantity of what? Quantity of product, which is the gas lah. Quantity of gas over change in time. So here the first one is 40 cm cube in 3 minutes. So it's 40 cm cube in 3 minutes. So we'll be getting 13.33 cm cube per minute. Okay, so please remember the unit. The unit is very important. This one don't have is okay. Okay, this is not necessary. This is for the explanation purpose. And the second set is 50 cm cube per 3 minutes. So when you divide as your calculator, you can get 16.67 cm cube per minute. So here you can see the rate of reaction for this second set. Okay, second set is faster or higher than the first set. Here you can see itself already. So here you have your first mark, you have your second marks, you get your 2 marks. Okay? Okay, so now the third question is they want us to compare the average rate of reaction for the first 3 minutes for set 1 and set 2. So for set 2, okay, set 2 is the one with catalyst. We all know that the average rate of reaction for set 2 is higher than set 1, or set 1 is lower than set 2 lah. But for this one in exam, please write okay higher. I'm just trying to make it faster. Okay, it's higher, set 2 is higher than set 1. And from here you get your 1 mark. And next, explain how catalyst affects the rate of reaction by using the collision theory. Okay, we have the catalyst, and we have to explain using what? Using the collision theory, which means that, okay, whatever bullet points that I've explained and discussed in the previous video in part 2, you have to write it here. So we're going to answer the question like this. Okay, the first one, okay, catalyst provides an alternative path with a lower activation energy, which is the EA lah, the activation energy. So when the activation energy is lowered, more colliding particles are able to achieve the lower activation energy. Okay, thus the frequency of we don't say about the frequency first. Thus the number of collisions. Okay, if can, please make it specific. Like for this experiment, what are we using? We are using the sulfuric acid and zinc. So this experiment, we are looking at the number of collisions between the hydrogen ion and zinc atoms become higher, and therefore the number of effective collisions, okay, once you have stated one time the hydrogen ion and zinc atom, the next time you can just write the number of effective collisions, the number of frequency. I left out the frequency. The frequency is not the number, it's the frequency of effective collisions between, because you have stated the hydrogen ion and zinc atom, so now you don't have to rewrite back. If you want to rewrite it back, you can, but for now I'm going to be using the frequency of effective collisions between the reacting particles increases, therefore the rate of reaction increases. increases with the presence of catalyst. So again, how many points we have? We have like what? We have 1 point, 2 point, 3 point, 4.5 points for 3 marks. If you ask me, is it necessary to write all these 5 points just for the 3 marks? My answer is yes. Because sometimes the answer scheme, or we also oftenly known as the schema, sometimes the answer scheme, they might have points for this, and this. But the other time, the answer scheme might have points for this point, and the last point. So you never know which point that is going to give you marks. So to be safe, please just write all these 5 points here, even though they only wanted 3, or even though only 3 marks are being given. You get my point? Okay, you get what I mean? Good. Okay, the last question, D. During the MasterChef competition, an apprentice found that a piece of meat is still not tender after cooking for 1 hour. It's a meat, It's one piece of meat. So suggest or state one method that should be taken to make the meat become tender in a shorter time, which means that you want it to be cooked. You want it to be tender, cooked in a faster period of time, which means you want a higher rate of reaction. Am I right? So we have to explain the answer. Okay, we have 2 marks here. Okay, we have one piece of meat. So what can we do to make this meat to become more tender? Obviously, the first step, please follow the question. Do not miss this point. Is that because we have one piece of meat, so what are we going to do? Obviously, we are going to cut. We are going to cut the meat. We cut the meat into what? Into smaller pieces. I like to write my answer in a longer sentence than to separate them into shorter sentence. So I will continue the answer. To cut the meat into smaller pieces to increase its total surface area over volume. Okay, and the next point, once the total surface area is increased, more heat can be absorbed by the meat, thus the meat will be cooked and tender faster. So you have here, you have your 1 point and the second point. This one it can be considered as 1 point itself also. So it's important that you write all the points, because you never know if the scheme if your answer is in the scheme or not, to give you the points. So now we have basically finished the entire chapter. If you have watched part 1, part 2, and this part, congratulations. I mean, yeah, it's good to recap, and you might miss some stuff that when you revise you might not notice. I hope this video can make a revision even easier and can help you to understand this chapter better. So now we are going to proceed with the summary. Okay, so now the last part, summary. What have we learned in this video? We learned about the experiments, right? We learned about the experiments. So the first factor that we learned about the experiment is the size. The size that time we are using CaCO3, calcium carbonate, or we known as large, and we use 2 different sizes. We use the large and the small marble chips. Okay, and we know that, okay, when the size becomes smaller, the rate of reaction becomes higher. Why? Because the faster carbon dioxide gas is being produced when you use a smaller size of this calcium carbonate or these marble chips. And the second experiment that we discussed just now is about the concentration of reactants. And the reactant that we're using is the sodium thiosulfate solution. the Na2S2O3. Remember the one that we have the conical flask, and then we, oh, my conical flask is okay. Remember the experiment where we use the conical flask, we put it on top the white paper with X marks, and then we start and stop the stopwatch when the X mark the X mark, the view completely disappear from the view. So okay, for this, because we're using this solution, that of course we are using different concentration of it by diluting it with different volume of water. So from there, the experiment, okay, the higher the concentration, the faster the X mark disappear from view, the higher the rate of reaction. Temperature. So temperature, obviously we change the temperature. We change the temperature of this sodium thiosulfate solution. We change the temperature of this, and we know that, okay, the higher the temperature, the faster the X mark disappear from view, the higher the rate of reaction. This experiment and this experiment, the apparatus and materials, everything is the same. The setup of experiment is the same. It's just that, okay, for this experiment we change the concentration of sodium thiosulfate solution. For this experiment we change the temperature of sodium thiosulfate solution. And the last experiment that we have learned is the presence of catalyst. And if you remember, the catalyst that we use is MnO2, manganese dioxide, or manganese 4 oxide powder. So how do we do that? Is that we took test tubes. Okay, we took 2 test tubes. Okay, one we just fill up with this hydrogen peroxide solution, and another one we fill up with hydrogen peroxide solution with this MnO2, which is the catalyst. And the decomposition, I repeat here again, the decomposition of this hydrogen peroxide solution will form water and oxygen gas. This one will ignite the glowing wooden splinter. So obviously this test tube, okay, when you put a glowing wooden splinter on at the mouth of the test tube, it will ignite. Okay, it ignites a glowing wooden splinter. Because the decomposition of this hydrogen peroxide solution is speeded up, therefore you get the oxygen gas faster, and for this test tube, okay, you get a glowing wooden splinter. So that's it for this chapter, which I've split into 3 part of the videos. So I hope you enjoy the videos. I hope it is understandable. And feel free to ask any questions in the comments. So thank you so much for watching. Bye.